Hello everyone, you're welcome back again. We're going to solve for the value of x from this Olympiad math problem. And the given equation is 8 to power x plus 2 to power x is equal to 130. And we are asked to solve for the value of x. To solve for the value of x from this equation, to make it easy, if you observe this equation, the middle term, 2 to power x, and the first term is 8 to power x. To make it easy, we can rewrite this 8 to power x in form of 2 to power x by writing 8 to base 2. So 8 to base 2 is the same as 2 to the power of 3, because when you multiply 2 by 2 by 2 in 3 places, it's going to give us back 8. Then all to the power of x, then plus 2 to the power of x is equal to 130. So the next thing we're going to do to make this 2 to the power of x in form of this, since according to power property of exponent, we can multiply these two power, so therefore we can switch the two power by bringing this x into the bracket, then we take this 3 out. So this term is the same as 2 to the power of x all to power of 3, then plus 2 to power x, which is the same as 130. So the next step we are going to do, if you notice, we have 2 to power x here, 2 to power x. So what we're going to do, we're going to use one unknown to represent 2 to the power of x in this equation. So let's use m. So we can say let m to be equal to 2 to the power of x in order to minimize this equation. So anywhere we see 2 to the power of x, we're going to replace m. But remember, we're going to come back to use this. So anywhere we see 2 to power x, we replace m. So here we have 2 to power x, which is going to be what? M to the power of 3 plus, in place of 2 to power x, we replace m, which is the same as 130. So what do you notice? Here we have what we call cubic equation, because the highest power of this variable m here is 3. And in cubic equation, our expectation is to get 3 possible solutions that will satisfy this equation. So we have different methods of solving cubic equation, but in this video, we are going to use what we call factorization method by using long division. And in using factorization method, the first thing we need to do is to consider factors of 130 that when we substitute, it will balance this equation. So when we do try and error and we get that one value that will satisfy this equation, then we use it as log division to get the remaining two solutions. So from here, you need to pay attention and watch very careful. So we have 130 here as a constant. So when 2 divide 130, we're going to get 65. Then when 5 divide 130, when 5 divides 65, we're going to get 13. Then 13 into 13 is going to be 1. So these three are factors of 130, though there are many factors, but we're going to consider just these three. So out of these three, if you notice 2, 5, and 13, if we substitute 2 to this equation in place of m, we are going to see that 2 raised to the power of 3 is 8, then 8 plus 2 is 10. 10 is not equal to 130, so therefore this is not the solution. So let's try 5. When we substitute 5 here, 5 raised to the power of 3 plus 5 equal to 5 to power of 3 imply 5 multiply itself 3 times, which is going to give us 125. The 125 plus 5 is the same as 130. So therefore, this 5 satisfies this equation. So when you try 3 to power 3, it will give us a large value that will even more than this 130. So therefore, the only solution that satisfies this equation is m equal to 5. And this m equal to 5 is the same as m minus 5 equal to 0 when we take m back, when we take 5 back to the left hand side. So we are going to consider this. Then at the same time, we consider our main equation, which is m to power 3 plus m equal to 130. This can also be rewritten in this form as this can also be written as m to power 3 plus m. When we take this constant again back inside, become negative 130, which is the same as 0. So this is the two equations we are going to use in long division. Remember, this one is the first value. So to get the second value, so using long division, this term is going to be inside while this is going to be outside. So we just forget about the equality sign first. And so this m minus 5 is going to be outside m minus 5. Then will be divisible by this. So m to power 3 minus plus m, then minus 130. And in factoring using long division, what we're going to consider is what we call DMS, which imply division, multiplication, and subtraction. When we divide the first term, only the first term to first term, then we multiply, then we subtract. So let's try. So m to power 3 divided by m, it will remain m to power 2. So this is just the first term to first term. Now we're going to multiply. M to power 2 multiplied by m to power 1, which is just m, is the same as m to power 3. Then m to power 2 multiplied by minus 5 is going to give us minus 5m to power 2. So now we're going to subtract. So we put our subtraction here, then we roll a line. M to power 3 minus m to power 3 is going to be 0. Here, there's no m to power 2. So here it's just like m to power 2 here is just like 0. So 0 minus minus is going to be plus 5m to power 3. So we're going to have positive f 45m to power of 2. Sorry, not m to power 3. So the next, all the term here is lost, which is the same as 0. So m minus 0 is the same as m. Then minus 30 minus 0 is the same as minus 130. So the next we are going to do, as you can see, what we have here is 5m to power 2 plus m, then minus 130. So we are going to repeat this again by divide the first term by first term, then we multiply and subtract. So 5m to power 2 divided by m is going to give us positive 5m because one of m will cancel. Now we're going to multiply. 5m multiplied by m is going to give us 5m squared. Then 5m multiplied by negative 5 is going to give us negative 25m. Then we repeat the last, which is subtraction. Then we subtract the two expressions. So 5m squared minus 5m squared is going to give us 0. So here we have m minus 25m. Remember, there's minus here and also there's minus here. Minus minus is going to be plus. Then m plus 25m is going to give us 26m. And here the constant is just like 0. So minus 130 minus 0 is the same as minus 130. Now the next step we are going to use is to repeat this again by dividing the first term. 26m divided by m and m is going to cancel. We're going to have positive just 26. Then we multiply. 26 multiplied by m is going to give us 26m. Then 26 multiplied by negative 5 is going to give us negative 130. Now we subtract. 26 minus 26 is going to be 0. Then minus 130 minus minus 130. Minus minus is going to be plus. So negative 130 plus negative 130 plus 130 is going to be 0. So therefore, this is the new quadratic equation we form. This is where we are going to get the remaining two solutions of m. So now we're going to pick this. First of all, we write our first one, which is m minus 5. We put it in the bracket, then we open another bracket and copy the answer we get from this long division, which is m to power 2 plus 5m then plus 26. Remember, everything is equal to 0 initially, so we equate it to 0. So the next step we are going to take is to recall that when two terms multiply itself to be 0, it's either the first one, m minus 5, equal to 0, or the second term, m squared plus 5m plus 26 equal to 0. So from here we can say m equal to 5. This is the first solution. Now to get the remaining two solutions, because this is cubic equation, our expectation is to get three solutions that will satisfy this equation. So here is clearly showing that this is quadratic equation. But for you not to go further and waste your time, there's what we call discrepancy. We are going to find whether the two solutions that is going to giving us after solving this quadratic equation are real number. So if the number is less than 0, that means it's called an imaginary number and we are not going to use it. But if the number is greater than 0, so these are real number. So to check whether these two solutions we are going to have at the end of the day is real number, we use what is called discrepancy formula. And the formula is given as what? Discrepancy, which is D is equal to B squared minus 4AC. So this can give us a positive solution when D is greater than 0. Now let's quickly solve for the value of D. And remember, in quadratic equation, we have what we call ax squared plus bx then plus c equal to 0, where a is the coefficient of the first term, b is the coefficient of the middle term, and c is constant. So with the help of this formula, we can easily get the value of b, a, and c from this formula. So d now will be equal to b square, the coefficient of middle square, which is the same as what? 5 square, minus 4 into a. A is the coefficient of the first term, which is 1, then multiply by c, and c is the constant, which is 26. So d now will be equal to 5 square imply 5 multiplied by 5, which is going to give us 25, then minus 4 multiplied by 1 is 4, then 4 multiplied by 26 is going to give us 104. So 25 minus 104 is the same as minus 79, and minus 79 is less than 0. So therefore, when you solve this quadratic equation, you are going to get an imaginary number, and we are not going to work with that. So the only solution we are going to work with is m equal to 5. Now we recall that initially we let m to be equal to 2x from here. We let m to be equal to 2x. So anywhere we see m, we just replace it back to its normal value, which is 2 to power x. So here that we have m equal to 5, in place of m here, we replace 2 to the power of x, which is the same as 5. So now, to solve for the value of x from here, if you look at this, we have 2 to the power x equal to 5. There's no way we can make the base to be the same. So we are going to take the log of both sides to base 10. So we take log of 2 to the power of x, which is the same as log of 5. And recall power property of logarithm. This x can go back and multiply the log. We have x log 2, which is the same as log 5. So the next thing we're going to do is to divide both sides by log 2, since we are looking for the value of x. So we divide the left hand side by log 2 and also the right hand side by log 2. So this is going to cancel. X now will be equal to log 5 divided by log 2. Recall that when we have log of a over log of b, in changing of base, this can be the same as log of 5 to the base of log of a to the base of b. So this is equivalent to this. This is what we call changing of base. This is one of the property of logarithm we are going to apply here. 5 represent a, while 2 represent b. So the whole of this can also be written as log of 5 to the base of 2, which is in this form. So therefore, x now will be equal to, this is the value of x, but if you want to get a numerical value, if you press calculator, log 5 to the base of 2 is going to give us approximately 2.322. So here's the value of x that satisfies this olympiad problem. Thank you for watching, and please, if you have any opinion, you can drop it in the comment section, and don't forget to subscribe to this YouTube channel.